On LR2-4, we're going to calculate missing angles in a triangle, and we're also going to use the third angle conjecture to solve problems, as well as the triangle sum conjecture to solve problems. So hopefully in that Desmos that we just did together, you figured out that, hey, the sum of the measures in the angles in every single triangle is 180 degrees. And I can prove this by literally drawing out on a piece of paper a triangle and cutting the corners off. And if I snuggle these three corners together, I should get a straight line. The internet also did some great things. And it's loading slowly. And if I play with this triangle, I can look and see that, hey, that sum never ever changes, even when all the rest of my angles do. Okay, they're always adding up to 180. Another good visual. If I change that angle, this red angle they're bringing over the blue and the green, and I can notice, hey, these three numbers always add to 180 even when I adjust them. Okay, and this is one that's easy to do on paper if you want to check yourself. We're going to think about two triangles then. So let's say I knew this one was 20 degrees and this one's 100 degrees. Most of you are looking at this and you're saying, duh, Miss Cronin, this one must be 60 degrees because I just subtract from 180, and you're not wrong at all. But I can take it a step further and say, hey, if I know the two are the same, even if I don't know what this angle is yet, I automatically know that the third is the same too. So if I know 2 in both triangles are the same, then I know the third one has to be as well. If I want to write that mathematically, I can say if 2 angles of one triangle are equal in measure to 2 angles of another triangle, then the third angle in each triangle must be equal. So we're going to do some examples, and we're going to use some algebra with this. So I'm looking at my triangle, and I have 3 angle measures, and I know they add up to 180. So I can use algebra and say 60 plus 65 plus x plus 62 must equal 180 degrees. So I'm at 187 degrees plus x must equal 180, so x must equal -7. I'm going to take that -7 and plug it in to solve for my missing angle. So I'm doing -7 plus 62 equals my angle, and I get 55 degrees. Again, this time 2 of my angles have algebra, but it's the exact same strategy. I'm going to add them all up. X plus 66 plus x plus 56 plus 82. I know a triangle adds up to 180, so I can set it equal to 180 degrees. 66 plus 56 plus 82 gets me to 204, so I have 2x plus 204 equals 180. When I subtract, 2x equals -24, so x must equal -12. I want to find the measure of angle B, so I'm going to take my -12 and plug it in to the algebra in angle A. Not B yet. So I've got -12 plus 56, and I get exactly 44 degrees for angle A. And now I have a choice. I can either take that same -12 and plug it in for the algebra up here, and do 66 plus -12 and get 54 degrees. Or I can say, hey, I have 180 minus, I already found 44, and they told me 82. It doesn't matter which one you do, because either way you land at 54. All right, on this one, all 3 of them have algebra in it, but I'm following the exact same strategy. So I'm going to add up my angles, 4x minus 12 plus 2x plus 16 plus 8x plus 8 I know my angle adds up to 180. And now I'm just combining like terms. So I get 14x plus 12 equals 180. When I subtract my 12 off, I get 14x equals 168. Divide by 14, and x must equal 12. To solve for angle A, I'm plugging this 12 in up here and doing some algebra. So I have 4 times 12 minus 12. 4 times 12 is 48. Minus 12, I get 36 degrees. Follow the same strategy for B. Take that 12, plug it on in. So I get 8 times 12 plus 8. And when I work that out, I get 104 degrees. And now I have a choice. I can either say, hey, 36 and 140, I've used 140 degrees so far. 180 minus 140, C must equal 40 degrees. Or I can say, nope, I like algebra and I like doing it this way, so I'm going to do 2 times 12 plus 16. And guess what? I still land at 40 degrees.